Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working in Chapter 4, problem number 4.1. I'll read the problem statement. Water enters a 2.00 meter cubed tank at a rate of 6 kilograms per second and is withdrawn at a rate of 3 kilograms per second. The tank is initially half full. Part A. Is this process continuous, batch, or semi-batch? Is it transient or steady state? Okay, so for part A, we're answering some conceptual questions. Okay, so for the first part, they asked us if the process was continuous batch or semi-batch. Well, this process is continuous. The definition of continuous is that it has steady flow in and out. Okay, steady flow in, steady flow out. This is a continuous process. Okay, then we have whether or not this is transient or this is steady state. Well, it is not steady state because there's less going out than there is going in. This tank level of the liquid in here is going to rise with time. So this is not at steady state. Okay, part B. Write a mass balance for the process. Identify the terms of the general balance equation present in your equation and state the reason for omitting any terms. So here's the general balance equation here. We say in minus out plus generation equals accumulation. We know that the generation is 0. This is because water is not generated in the tank. We know that in the tank, the water going in is because water is flowing in. They gave that to us. Water is flowing out because they showed us how much water was flowing out at a steady rate. There is accumulation because 6 is more than 3. And so that's our accumulation term. More water in than out, the tank level will change with time. Okay? How long will the tank take to overflow? Okay, so let's write down our mass balance. We have mass going in minus mass going out equals our change in mass with time. Mass going in minus mass going out. Let's say that the density of the water is not changing with time. So we can pull the density out of this density times volume equation, pull it out because it doesn't depend on time. Okay, so now we have a volume change with time. How much water volume there is in the tank, how does that change with time? Okay, now we can integrate with respect to t, and we get this function. Don't forget the integration constant. Then we divide by our density here, and we get c star. C star is this c divided by rho. It doesn't really matter, they're both constant, so this is just our new constant, okay? And now we have a volume function with respect to time, okay? So at time equals 0, what does C star equal? Well, they told us the tank was half full when time equals 0. So it equals 1. Okay? So then we have our full function defined here. This is the density of water. This is our mass, in and out, and our time in seconds. What does the time equal when our tank is going to overflow? When the water level is at the top of the tank? Well, we can just rearrange this equation that we have, put it in terms of t, and then we can solve for all of these rates. Each one of these things is known. Okay, so that's what that is. Make sure you convert the units appropriately and things like that. We see that it's 333 seconds. We can also convert it into minutes so that it's a little easier to tell how long that time has passed, because it's hard to tell how long 333 seconds is. So it's about 6 minutes. And that is it for problem number 4.1. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.